Hi, good afternoon. My name is Zach. I'm from Neuron Mobility. It's been a very long day with lots of technical information about ArcGIS, and I think now is the time to be a little bit more relaxed and talk about something not so technical and hopefully fun. Neuron is a transport technology startup that works on providing a data-driven, short-distance mobility sharing system based on electric scooters and highly modular docking stations. It's a full IoT system that allows real-time tracking, real-time analytics, and even real-time controls. We have sensors, control board, and GPS built into every scooter and station. We like electric scooters for its space efficiency and its ease of use. We are not scooter fanatics that love the scooter so much that we try to build a system around it. The form factor is actually the result of a number of serious analyses. And today, I'm very happy to be here to share with all of you for the very first time how Neuron tackles the last mile problem with a combination of artificial intelligence and geospatial technologies. Cities are getting more populous than ever. It is getting denser and denser and richer. And many city governments start to realize that building more roads for cars is not going to solve the transport problem in the long run. In fact, it might even create more congestions and more pollutions. And many came to the conclusion that car-lite is the way to go to keep cities sustainable. There are a few ways to go car-lite. The first is to make cities more walkable and cyclable. The Singapore government recently announced a plan of 700 kilometers of bicycle infrastructure to be constructed. At many times, behavioral changes will come when the surrounding infrastructure change. And the second is to increase the utilization of the existing road vehicles. Technology companies like Uber and Grab has done a great job trying to achieve it. The third, but not the least, is to get more people on the public transport itself. When done right, this can be the most effective measure towards car-lite. However, the last mile problem is one of the biggest obstacles to get more people to use the public transport. I personally have a last mile problem at work myself. And I'm sure many of our friends at Esri share the same problem. My office is at the heart of Jalan Pemimpin, which is roughly about 12 or 15 minutes away from Bishan MRT or the Marymount MRT. And there is simply no public transport service into the area. And every morning, I see many of the other co-workers in the building come into work with lots of sweat. And I need to drive many of my colleagues out for lunch whenever there's chance, because no one wants to walk under the hot sun at noontime. The last mile problem is a difficult problem because of a low density and frequency of demand. And it is very difficult for the traditional mass public transport service to address those needs in an effective manner. But we are certainly not the first one that tries to tackle this problem. In fact, it has been quite a hot topic these days. There are two main categories of solutions that's commonly seen in the market. And the first category is what I call a device innovation. These are self-owned devices like e-scooters, hoverboards, Segway, mono wheels, and so many more to come. While these device innovations can be a nice hobbyist product, it is hard for them to be the last mile solution for the mass. The self-owned devices are just inconvenient to use. But I mean, the riding part is fun, is nice and comfortable, but not the carrying around and the parking part of it. I was a scooter user myself, and it was very embarrassing every time when I carried the electric scooters into the MRT during the peak hours. And I just can't imagine myself carrying around the scooter, moving in and out of the shops. My wife does the shopping. But the biggest problem of them all is it's very difficult for the government to enforce the safety regulations on the PMDs. And Singapore government came out with the rules and regulations on the speed and the weight limits for the PMDs early part of this year. but it's just going to be a very difficult task trying to police and to control it. A few days ago, a lady was knocked down by a scooter rider and still unconscious till now. And another scooter rider traveled at 70 kilometers an hour on the electric scooter, overtaking a bus, has stirred lots of unhappiness on the social network. The exponential growth of these self-owned personal mobility devices will create even more problems until there's a proper way to control it. And the second category of solutions is the bike share system. The bike sharing has become very popular in the past 10 years all around the world. There are almost 900 bike share systems deployed with different fleet sizes. They served well as an alternative mode of transport and is popular in cities like New York, London, Paris, or even Taipei. And in those cities, instead of taking a bus or train, the commuters just grab one of these bicycles and go to work. While bicycle sharing is a very nice alternative mode of transport, it can't solve the last mile problem. And not to mention, none of these 900 bike sharing systems actually makes money without government subsidies. If you look back to the history, you'll realize that bicycles was never actually designed as a last mile solution. This year marks the 200th year of the invention of bicycle. It was invented way before there was even cars on the street. It was invented as a primary mode of transport. And because of the large wheel size, the frame, the seat, and the handlebar, which actually didn't change in the past 200 years, it became a viable solution for people to travel 5, 10, or even 15 kilometers. This is the fun part. But also because of this, it is just too large for it to be a last mile solution. An average bike share station takes about 1.5 to 2 square meters of space per bike. I just can't imagine how government is going to allocate 1,000 square meters of space to cater for 500 bicycles at the MRTs, which might be the capacity of the station needed at some of these key transport nodes. And so when we decided to approach this problem, we realized that we need to take a top-down approach by understanding the network requirements before we even start on the hardware. And the solution needs to be something that combines the system, the software, and the hardware together. And to make it commercially viable, we also need to consider operation and maintenance of the system early from the design phase. And most of our bike share system failed because of the extremely high operation and maintenance cost. So the conclusion we made was that we are going to build a hardware system that is 10 times more space efficient than any of the bicycle sharing system you see. And beyond that, we need to start building a brain that interconnects every part of the system. So what is this brain? It is a combination of many different functional units that senses, learns, and controls the design and operation of this network of mobility devices. And the objective of the brain is simple. It optimizes the daily operation, increase the utilization, and reduce the maintenance cost. So from the design stage, we look at building demand model, site selection, station capacity, fleet size, and at operation and maintenance, we build predictive maintenance models, redeployment models, midnight and midday rebalancing models, and even battery charging strategies, all through a consolidated platform of an artificial intelligence system. So we started the deployment from analyzing the potential system. The challenge of the system study was that there isn't any available data set for analysis because there is no such system being deployed in Singapore. So we decided to synthesize a data set that simulates the flow of short distance trips. And without geospatial technologies, it would have been something very difficult to achieve. And to synthesize this data with limited information that we had, we used Esri's routing engine to figure out the scooter path based on the walking routes and extracted the XY coordinates for every few meters around the route to create a real-time tracking of the scooters. And the ability to do real-time tracking enables us to do many other things. And we have even built a virtual environment using this information to simulate the entire back-end software system that we have constructed. We build a strong understanding of the amount of communication, simultaneous user requests, and data flow of the system before we do the actual deployment. And by visualizing the inventory and unmet demands in the simulated network, we started to see interesting trends. And for example, in this plot, the blue color circle symbolizes the inventory of the scooters in the station, and the red color symbol shows the unmet demand. As we can see here, there are a large number of scooters in the southern part of the network when there is almost no demand after certain hours. And there is a big unmet demand in the northern part of the network that has not been served. And this triggered us to think about the midday rebalancing possibility and study the impact of midday rebalancing over the overall utilization of the system. So we tested a system with rebalancing that moved some of the unused scooters from the southern part of the network to the north. And this helped to relieve the morning unmet demands in the north. After we repeatedly did the rebalancing for a few times, we actually increased the overall system utilization by 40%. And of course, we are feeding this information back to the brain that interconnected with the cost of rebalancing, the potential revenue increase to decide whether such rebalancing would actually make economical sense. And we have also applied different machine learning algorithms to optimize the system operation. And in a comparison here, you can see the difference between optimized and non-optimized system. We basically optimize on the initialization of the system. And we managed to increase the utilization from 11.6 times per scooter to 14.11 times, and reduced the number of unutilized scooters from 120, which is about 12% of the entire simulated fleet, down to 1. And we have also managed to achieve a better distribution of the usage and lower the maximum inventory of scooters at the busiest stations. And in this case, it was the Boon Lay MRT station, and we reduced the max number of inventories from 450 to 160. And in the planning of this system, we not only look at the demand and utilization of the system, we also study the impact of changes in user adoption and the fleet sizes on the existing pavement infrastructure. So we did scenario analysis to ensure the system that we deploy is not beyond the pavement holding capacity. We have done so by using ArcGIS to study the density of PMDs in a different part of the network throughout the day. And in the plots here, you'll be able to see the changes in density of scooters on the streets when there is a change in the user adoption rate as well as the fleet size. And there are still many ongoing development work that we're doing, leveraging the strength of geospatial solutions. And for example, we are trying to automate the site selection process using ArcGIS. And different from buses, which is usually 400 meters apart, and MRT stations, which is usually about 1 kilometer apart, we're trying to deploy a much denser network. And it is crucial to select the best sites for the stations in order to bring real convenience to the users and increase the utilization of the system. So we are also working on utilizing some of the available APIs to define the algorithm to self-generate the most efficient rebalancing plan to the operation team. And it is a matter of how many trucks and how many operators are required, how many scooters should they pick up or drop off at each station, and what is the best route for each team. And the results of this will help to minimize the cost of operation and enhance the commercial viability. So we are currently in discussion with the agencies and private building owners to look into the deployment of the system in the very near future. And we are going to do a launch at the end of this year. And we are happy to work with different government agencies to look at the potential effect of deploying such self-service system to their network. And I would like to take this opportunity to give my special thanks to Leslie and Thomas and Andrusha for their strong support, and also Casey and Thibaut for their excellent knowledge in ArcGIS into making this project a reality. Thank you.